This is the Tesoro AI podcast with Darius Gant. AI is changing the world and fast. This episode is coming to you courtesy of Tesoro AI, the #1 recruiting service for software development and AI talent.
All right, Maria, welcome to the show. I appreciate you taking some time out to join us.
Thank you for having me. Excited to chat.
Absolutely, absolutely. So I was interested in your background. Saw you had completed a PhD. Correct me if I'm wrong on any of the details, but done some PhD work focused in chemical engineering and then moved into the startup world. Would love for you just to give us more context, provide the listeners, right, with more context to your background, as well as kind of, why AI? What interested you about AI?
Sure. Yeah, no, happy to. Yeah, so I was actually born and raised in Mexico in a manufacturing town. So I've always, my background's actually mechanical engineering, although chemical would be pretty cool.
Yeah, there we go. I changed up those letters a little bit.
Yep. But yeah, I just always loved working with machines, fixing things around the house with my dad was kind of my thing. But I also, being in a manufacturing town, got to be exposed really early at like how different things are manufactured. So our town was known for like cars and denim jeans. And you see car, factories and it's robots and it's automation and all of these things. And then you saw denim factories and it's like people, usually women, hunched over, sewing over these things. And
Right.
I always kind of had this like, that doesn't seem right? Like, why don't they get the cool stuff? And only the cars do. So that was always kind of the motivation. And I just like fixing things. So as you mentioned, ended up going to MIT for my undergrad, stayed there through my PhD because, I just love the research. I love the learning. And it was there that I got more into robotics. So I always like building things, but robotics was kind of my introduction to AI because, in some ways, robotics needs some sort of AI. Right. To be fair, very primitive to start with. Now it's much more advanced, but that was kind of the drive to it. And it was during graduate school that I was working on a DARPA project, and DARPA was looking at like, hey, we need cheaper, almost disposable robots that we can deploy for other things. So we were partnered with Boston Dynamics. We were working on this project, and that's where I met my co-founder, Kevin Albert. And so after I finished grad school, he was out here in San Francisco and, kind of matched up. He's like, I just got a government grant. We can work on this idea of like, how do we approach robotics in non-traditional environments, what we call unstructured environments, right? Not a car manufacturing plant where everything's nice and controlled, but how do we get robotics into other places in the world? And so that's how the startup came to be. We both kind of had this dream to put robots in other places, and, that we had the opportunity to make that happen.
Interesting. So when you think about, I can see one of the major things is how can we leverage robots in a world outside of, an Amazon facility, right? There are a ton of things that we imagine. There's a ton of things that we imagine that can be done, but it's still in that world of sci-fi, right? What is, in terms of us getting to that point, because I think that's where you all are pushing us towards, but what's the major challenge there that is preventing us to moving from that, hey, we've got some robots, we got AI inside of like a facility. Okay, but what about the real world? Like, what's that gap?
Yeah, I would say there was probably 3 gaps in my mind. And I think we are right at the point where those gaps are closing, which is what's pretty exciting. Early on, hardware was limited, right? Like the amount of sensors that you need to be able to react things, like you said, not in a structured place where a box will always arrive at this spot and then you just move it from here to here, right? The robot doesn't really have to think or sense. It just assumes it's there and it acts. Right. So the sensors were needed. And that's where autonomous vehicles actually really helped out. There was a ton of funding put into that. All of these sensors started coming down like LiDARs and stuff, right? I remember when we started, we would spend something like 20 grand on a LiDAR. And now you can get these things for like under $1,000. And so you're just, also the equation changes, right? Throw an extra one in there. You get more data, which we love data. Right. So that was one gap. Another one is the AI part of it, right? I think we were just our ability to process that information and make reasonings with it, right? It was still the computing power wasn't there. And also the models were just not as advanced. So a lot of the robotics, artificial intelligence was more like, you see A, do this and this. You see B, do this and this. So, very limited intelligence, if you will. but it worked for those structures where you didn't have to react. And then I think the third gap, which I see is more business driven, is there was a lot to do in those structured environments, right? There was enough cars to build, enough Amazon delivery, that I think it was also easy for roboticists to, let's go tackle those. Yeah, it's like, that's easy, right? And so that's a little bit where I challenge our engineers. It's like, we've been doing kind of the easy stuff because it worked. If we want to do the hard stuff where it means pulling people out of places where, what we do is like sanding and people are covered and inhaling all of this dust, we're going to have to go a little bit into the harder stuff, right? But I think with the sensors and the computing and the AI coming together, we're at a place where it is possible to do those things because you don't have to be so structured anymore.
Yeah. Okay. So sensors was issue number one. AI, compute power, issue number two. Issue number three is first just, making sure we tackle the low-hanging fruit. Okay. So as you think about Canvas, I guess you did mention that some of the low-hanging fruit you have tackled. Would love to get some sense of, some use cases, right? For some of the more simple things. And then potentially, like, where could we go? What are you all shooting for? And if we were to envision a world where we do have robots in non-controlled environments, like what does that actually look like? Not just what it looks like, because we've seen it in sci-fi, but like what's more realistic?
I love how you changed that question at the end, because I think we all have like this dream, right? I still remember that DARPA project. One of the first things they pulled up was the Terminator scene where he's like coming out of the liquid and they're like, we want that. And we're all like, okay,
yeah,
how much money? But what it more realistically looks like, at least the way we think about it now, is robotic tools to enhance those jobs, right? Let's start protecting the people. Let's start giving them kind of advanced tooling that is robotic. It allows them to not have to put their bodies on the line to do the work. That robot may have different shapes or form. I think there's a lot of people right now in the humanoid robot camp. I think it's interesting. We're going more for the approach, like a faster path is more the augmentation of the worker, the protection of the worker. It doesn't have to be humanoid, right? Wheels work really well in certain environments. And so that's what, with Canvas, what we said was we had figured out through our research work that we could operate in these unstructured environments, partly saying like, we're going to have to be relying on there's some error, right? Like we can ever expect to have sub-millimeter precision.
right.
So how do we develop our algorithms such that it can, centimeter level is okay. And so when we did that, we then were looking for what's the right place to start. And for us, it was construction, just this humongous industry, which is still super manual. You see the productivity compared to all the other ones and it's dropping, right? Everybody else is like, woohoo, we have new tools. Construction, we do drywall finishing specifically, and the tools they have are like 50 years old, right?
Okay. So how does that look, right? Like, are you all creating robots, infusing them with artificial intelligence, and then are they, kind of, what are they actually doing? I don't know anything about drywall finishing, first of all. So what does, just to kind of make this more concrete, right?
Sure.
What does the robot do? And what is it that the AI does uniquely that the existing tools that someone who's in construction doing drywall finishing, what is the AI doing that was not possible, I should say, in the past?
Sure, yeah. So drywall finishing, and we specifically started with this trade because it's very manual, very dangerous in terms of exposure. But to your question before, our vision is, robotics and construction. But in drywall finishing, it's all about, you hang up the drywall. It looks kind of like a quilt almost of like pieces. And the finishing is to make it look, you want your wall to look like one wall as opposed to this quilting. So the finishing's just applying this material, trying to smooth it out so that visually it will look like one wall. So usually what they do is they apply it, they sand it, they wait till it dries, apply it, sand it, apply it, sand it. People have figured out a process that is as little sanding as possible. What we said with the robot is you don't have to do that if you have really precise control, right? And robots are good at precision, repeatability, not so good at adaptability, although AI is kind of helping us with that. And so when our AI came in, right, the fusion of all the sensors allows us to detect where is the wall, where can we find it? And then we use machine vision, kind of one of the earlier forms of AI to find those intersections and then to classify those intersections to say this is because they're different type of, because it couldn't be easy, right? There's different type of intersections, there's different type of defects, and you have to cover all of that up. And so we use the machine vision and then our algorithms and our models to identify, okay, this is what I need to do in order to make that look smooth. And so I apply material, I sand material. So it's all about that perception that for a person comes inherent, but you need AI to do that perception and then translate that into a set of instructions for the sprayer and the sander.
Got it. So like hypothetically, you could leverage a robot with some sort of deterministic software to do this, right? But that would mean that either one, you've coded in all of the different types of wall parameters that you have, or two, you just use one type of wall and you have one set of code to do it. But because you've got computer vision now, in the same way a human would identify, okay, the wall stops here, right? Because of XYZ. The AI is doing something similar where it says the wall stops here. So I have to finish my drywall finishing process here versus plowing through the wall, right? Or leaving a section undone.
Exactly. And I think you nailed it, right? In the past, that's why manufacturing could do it, because they just said, we're just going to show you the same wall, right? We're going to show you the same car. You don't have to think, you do the same thing.
Right.
Construction had that problem, right? Like, this building is new. Nobody's ever built it before. And on top of that, while we build it, we change it. So it's almost like, how could we even tell you? And so you needed that AI to say, everything's going to be different. How do I identify it? And how I use my previous knowledge, right? That's kind of the more exciting part of AI now, is like, I may have never seen this before, but I've seen things similar to it.
Yeah.
I'm going to act on it. And we, on top of that, especially as we're building those models, use the person to also help with that, right? The person can also be like, hey, you know what? You're missing a little bit here at it. So how do we kind of build all of that to the point where later it won't have any problem seeing something new and acting on it?
Okay. So one of the things that's interesting to me when it comes to robots and leveraging AI to do human-like things is the robot's ability to sense pressure. So, you see videos of a robot picking up an orange, peeling an orange, and at the same time picking up something that is a little bit more sturdy. Is that something that you have to take into account from an AI perspective with the drywall, right? Like, are there scenarios where it could punch through the drywall if there's too much pressure? So the AI needs to recognize that and understand, maybe there are different types of drywalls. It needs to understand, okay, time, place, scenario. Here's how much pressure I apply in order to accurately finish the drywall.
Yeah, and it really does, because drywall joint compound, as it's called, or mud, you hear it called, is super soft, right? Like, you can go with your nail and scratch it. And so even though maybe we won't punch through a wall, you could sand it terribly, right? You can remove everything you did the day before, and you're like, the robot be like, cool, if it's not monitoring that. Or you can not remove enough. And again, the person would come back in and be like, wait, what just happened here? And so we do use a lot of contact force control is super critical for our application. Anything soft, right? And just delicate, we need to control that really tightly, and then also sense that feedback. So I do think that's also one of the things that humans have. So whenever we think of, like you said, a task that a human's done, we use touch so much, right? And it has been kind of the one thing robots didn't have. We have a lot more vision sensors, but it is a critical piece. And I think the more that improves, and there's even people working on even better sensors around that, the more like these tasks that have been almost unreachable, because like, oof, you use a lot of touch on that one, will start to become more feasible. For us, that force control in the sanding is crucial. Without it, we just, we would do a terrible job every time.
Yeah, I don't know if you've seen the movie Atlas with Jennifer Lopez. It recently came out. So she's basically, I don't want to ruin the movie for folks who are listening. But basically they got these AI robots, right? And in her, she can hop in and she becomes like a soldier, right? But she's resistant to it at first, but it has all this intelligence built into it. I don't want to ruin the movie for anyone who's tuning in, but it's a great movie. I was going to ask you, like, how what's the distance we are from that? But I'll leave that there, and I'll let folks you yourself. I'll let you tune in if you decide it's interesting enough.
Yeah.
But so we have a lot of episodes where we talk about building AI, but within the context of a software only business. What's the difference when you have to also think about infusing AI into hardware? Are there a few things where, maybe you have to think about things differently, or maybe you have to think about additional steps? I'm curious, what your thoughts are or your experiences are with that.
Yeah, no, I think it's a super, kind of takes it to the next level, right? There's two things that first come to mind right away. One is you have inherent differences or parameters that you have to tune just because of the hardware. So it's not even because of what you're trying to do, but a motor is going to behave a little bit differently. So you need your AI to help you also know how to react to that, right? And so your motors, your sensors have noise. And so not, in the software, I think you can say, okay, this is the input. I have all my data. I have an output, but this is my input plus the noise that my own hardware puts into it. And then I have to react. So there's AI that you have to do just on your own understanding of your model, even before you try to sand or spray of your robot, right? And then the other piece is getting that data is a lot more difficult, right? A lot of these large language models grab all this data available. For us, there's no data on how a robot sands a drywall finishing. And so it requires a lot more of creating your own data, right? There's a really interesting work right now on foundational models for robotics, but it's all about who has the data, right? And who's creating it. And so I think that's the extra challenge. And for us, it means I have to hang hundreds of thousands of square feet of drywall, right? Like that's just not tenable. And I think the really interesting part that back to maybe the other thing that's helping close the gap is the simulation environments are getting really good. And so NVIDIA's been doing amazing work there, and we are leveraging simulation and saying, okay, I can't hang and finish, right? We just don't have the space or the time to do that. But on simulation, I could run through all of these different parameters, all of these different layouts. It has to be supplemented with real data. So we do have to hang some drywall. We do have to get robots out there, and basically our models have to be rebuilding themselves very often. But simulation helps close that gap versus somebody just leading with language. And even then you hear them say, we need more data, right? But they find other ways to get it. But we just don't have that data available, right? A robot hasn't done this before. So you have to create your own data sets, which is tricky.
That's so on one side, it's a very manual process for collecting this data, right? I actually have to create a robot that then does, in the example that we can continue with the drywall finishing, right? The simulation part is interesting. How close, right? Because you can use the data from the simulation to then train your model, but how closely, I'm just, how accurate can that data be? That part is lost on me. Like, can I really create a simulation that can then help me to do a better job in the real world? And I guess we already have examples of, pilots using simulations to train, but, on the side of like, okay, so that's a human paying attention to a simulation, but what about a robot learning from a simulation? Can we create a world that's close enough to the real world that the robot that can then operate effectively in the real world?
Yeah, it's definitely tricky. I think it requires cycles, right? You need to have the real data to create your simulation, right? So I think that's a lot of the foundation, right? The amount of scans that we've done of what is spraying joint compound onto different surfaces, because then you can feed that into the simulation, but without it, right? Like, how is the simulation going to know what is the thickness that you spray at this speed under these conditions? So it does require a lot of building it. Luckily, I think now with the shared simulation, things that maybe we don't have to build from the ground up is the data on the motors on the robot, because this is where people can collaborate. We use a robot arm that other people use. So hopefully at least that part of it, you don't have to do, right? If you have an engine. But the end part, you have to do it in real life and feed it in, do it in real life. But then after that, though, the nice thing is like, I don't have to do in real life. What if I spray at 1 millimeter, 2 millimeters, 3 millimeters, right there, I can use the simulation. One of the most powerful, or probably the most common uses right now, is like synthetic images, right? I was telling you about machine vision. I could go take 1 billion images of drywall. It's going to take me a long time. Or I take like 1,000, and then I use synthetic images to move that joint, not here, to the bottom left, to the top right. What if it's darker? What if it's brighter? What if it's, purple in the background? And so and we've done this with our own models, you create synthetic images to help you. But at the end of the day, you got to have your core data of real images to then test it, right? And validate it and see. But the synthetic images, at least, I think that's a pretty well tried and true. You can get pretty good response. The robotic simulation, it's a lot of what you put in is what you're going to get out, right? You got to make the time to make sure the basic foundation is good. And after that, yes, we can trust it to give us good data.
So will the production of synthetic video, would that also be a data set that would help for what you all are trying to accomplish with robotics?
Yeah, I think in several ways, right? One would be just I have to deal with a crowded work site, right? There's people doing other things other than drywall. There's my own worker. And so the video would help us also with simulating that, right? How do we keep everybody safe? And it's a great way to test environments, right? What if we change this? Okay, we bumped into somebody in simulation.
Yeah.
That's cool. So I think for that, and then also like images, video, back to like if I had just video and video of different drywall configurations in different buildings, you can again test your algorithms and make sure that, okay, I can finish that funky wall, right?
Right.
My algorithm can take all of that in. So I think it's super interesting. And the nice thing with some of the more just this is what a busy construction site is that could be used by several other people doing other things, right? The drywall specific, maybe you wouldn't be as interested, but you might care about like what does a person moving in a construction site look like so that I can make sure my robot can operate there.
Yeah. This topic is, I find it exciting, especially having seen the demo for Sora. We don't know in actuality how it really works. But the demo for Sora was interesting in how realistic the video was.
Yeah.
When you think about video and how you use it today, what are the types of videos, if you are using it right now, but what are the types of video you're able to use? And then does that step into the world of leveraging LMs for video production, creation, imagination? Does that then, well, once it is available broadly, is that then something you can implement into how you build out AI-enabled robots?
Oh, I like this. It's like, how do we use other AI to build us I like this. Yeah, I mean, use video to some extent, not a ton yet, but as we're adding more and more autonomy, it becomes more and more important. I think the video level that we're getting right now is probably good enough because I'm not asking the robot, at least for us, to tell me if you were happy or sad, right? And we're that little like subtleness. And there is reasons that LLMs will need that type of level, right? If you are trying to, hey, maybe a sales tool that tells you is this person engaged or not. Luckily for us, I just want to make sure where you are. I can see where your hands are, right? I can see where the simulated person is. We'd want to make sure it's realistic, right? They didn't create something where a person's flying and now the robot's freaking out because I've never seen a person flying before, right? But I think from that level, we care more about the accuracy of like the movements and all of that, which I think this is where the data set is really good, right? Because they're using real people and we care less about the specificity of what they're doing. And so for us, it is already, I think, at a point that it could be really helpful. I think people who are more trying to have a robot interact with a person, the subtleness of it is probably what's going to take a little bit longer to get just right. But I think for us, it's in a place where how do I avoid you? How do I move around you in a safe place that I'm not going to create it? I think we can use a lot of, AI generated video and images to help us as a training point, and then you just test out the final results with real data.
What are some of the use cases that you see maybe 5 years down the road as it relates to robotics, 5, 10 years down the road? What are some things we can, again, getting back to the kind of what's realistic and what's like pie in the sky, but like 5, 10 years down the road, if we were to conceptualize some of the use cases that might be on the roadmap, what are some of those things?
I think in general, we'll be seeing them in a lot more commercial settings. Construction is a perfect one where I think that we're already getting a lot of people. And honestly, we need it, right? There's not enough construction workers joining. Like basically for one person that joins, 2 people retire. So we're kind of in this problem where we have to build and we don't have the people to do it. And to be fair to them, I get why they don't want to. It's like, hey, destroy your body.
Right.
Join construction. So I think things like that is my hope. And that's where I think there's a ton of business case for these robots that maybe, can't do it all. They're not humanoid. They can't wash your dishes while also doing drywall finishing. That'll be interesting, but they don't have to be, right? Just like we don't have, workers that do everything, they get specialized. I think we'll see more of these robots that are able to deal with unstructured environments, able to support, but they have a mission and a purpose, right? And it is to do these tasks and probably a variety of tasks, but within this constraint.
Yeah.
A little bit farther down the road, I think the multi-purpose, there's a ton of development, but I can see that it'll still take some work, right? Because that's now the other challenge they have is your hardware has to be generic enough, right? My hand, to your point, has to peel an orange, but it also has to be able to pick up this heavy thing. It's people are amazing. Human beings are ridiculous in terms of hardware, if you will. And so I think that those more purpose-built humanoids that can do anything, you have one in your house and it'll do any task for you, get difficult because you have an iteration on hardware and AI that has to happen, that'll take longer versus saying like, there's enough problems right now. It's okay if I don't do it all, but if I do this one thing really well, I can get people out of that dangerous spot and I reduce my challenge, right? I don't have to create the hardware that does it all. I have to create a sanding head. Okay, we know how to do a sanding head. Let's do that. So I think at least that's my hope. And I do think it is very reachable within 5-10 years that you'll see a lot of blue collar workers having robotic tools, right? Really augmenting their work because there is the technology to allow them to do that.
Yeah, the thing that keeps coming to my head is the person who's like hanging from a skyscraper. One, a person hanging from a skyscraper washing a window, or some of those like old school photos you see where you've got, you know, 3 guys eating lunch hanging off some pole that's like extended from the Sears Tower, I guess the Willis Tower, or some other like large skyscraper, right? Some of those more dangerous jobs where you're like, yeah, we're gonna stop, you know, hoping that there's not a gust of wind that sends you to your death.
Yeah, no, I 100% agree with you. There's just jobs that the only reason is we don't have no better way. And all of the other ones that I look at is things that sanding, right, as one of our value propositions, we're exposing people to all these things. You know, OSHA's been trying to change the regulations, but because there's no solution, they have to keep delaying. So they know it's bad, but it's almost like we have no other way. And so we're like, okay, let's wait another year. Let's wait another year to implement it. And that's not the right thing, right? We're putting people's bodies and health as a solution. We see all these when we were looking with government, you know, nuclear waste, and they send people out there even though you shouldn't. So I think that's the kind of stuff that robotics really should be pushing. And saying like, let's have, those people are still needed. They are super capable of saying, how do you do this? They can stay on one site, right? Send the robot. Same with us, right? We always say we keep the person on the ground. In construction, most of the injuries are falling from a ladder, falling from heights, right? Different things. So if the robot can go up and you stay down and you kind of direct it and give it feedback, you're already way safer than if you had to go up on the ladder or the scaffold.
Yeah. So the conversation we had around data was super interesting because it's a conversation that extends beyond what, you know, if you, like I talk about deterministic software before, it's really, look, we've got our front end engineers, we got our back end engineers, and we're going to put a product into production. But when you extend that to AI, right, now you've got this data you got to work with and you've got an AI model. So you kind of taking it in other steps, and no, we actually got hardware too. Right, so we're gonna give you all 3, maybe with the exception of some graphical interface, right? But to launch Canvas, what were some of the core pieces specific to an AI-enabled hardware company? What were some of the core pieces that you all needed to focus on bringing in first to get off the ground?
Yeah, and that's always, I think, the challenge with robotics, right? It's so interdisciplinary. So you have to have your mechanical engineer who's going to kind of build it, electrical.
That's you,
sure.
right?
That's me. That was me. And into electrical until we could get a better electrical engineering. You know, there's always often people call themselves robotic computer science, right? It's not just software, but robotic, because they tend to be much more comfortable with that interface of hardware, right? There's firmware that we often deal with that people don't have to, right? And it's a little bit of a specialized people who are writing firmware versus software. So we have all those. Like you said, we do have some front end, although that was less important at the beginning because we just, you know, whatever the UI looked like, we were going to deal with it, right?
Yeah.
But the piece that, as you get into the task, is we also had to bring in process engineers. These were people who understood how the material was going to be sprayed and sanded, and how do you develop a model. And then we brought also simulation engineers to the point that we said, so we had somebody hired just to do, like, you have to own our simulation, you have to, you know, work with the process team to get the real parameters into it. But it was somebody who just could live in the simulation world and then runs any code that we do through a simulation environment before we even put it on the robot, right? And that allows us to catch any problems that could be catastrophic. Because as you said, deterministic, the part that we haven't touched on, but I think it's super important. It's like in LLMs, a little bit of dreaming, a little bit, like, it's good, right? It's the creativity.
Right.
In robots, you don't want any of that.
No,
right?
I cannot have you hallucinating.
You don't want this robot be like, oh, I want to spray over there. That could be cool.
For sure.
And so the safety level that we deal with, right, at the end of the day, there's a non-AI driven, there is just a very simple, hard-coded, right? It lives in its own chip because you can't even have like a shared computer for this type of level. And that's the safety level, right? And that's super core. And so in general, we have a little bit less of this hallucination, more of this, like, you want it to be creative and coming up with solutions, but it also has to be deterministic, and it can't ever step out of the box where it could hurt somebody, right? It should never spray if it's not at a wall.
Yeah. Well, in thinking about that and what's unique to AI, the fact that it's probabilistic and not deterministic, you all have to be very accurate. Was there a starting point as it relates to the accuracy of your AI model and saying, well, here's where we are, here's where we need to be. And then how close to 100% do you need to get before there are kind of diminishing returns?
Yeah. A couple of things. I think for us, the human in the loop, right, has always been a little bit of the solution to that problem. So to start, we have a lot of this, like, okay, at the end of the day, person, you confirm, right? I came up with all of this. It's very hard for you to come up with, and you're not a coder, but confirm, right? And for example, with the joint location, confirm that this is what. And for those, we see that's actually pretty fast to get to a high enough accuracy. And to your point, like, getting beyond like 95% is pretty hard, right? You, at some point, there's too many things.
Right.
But you don't have to be perfect. Honestly, if we spray the wrong place, we can live with it in 5% of the time.
Yeah, you can redo that.
Ideally 99%. But the other one is that we often think about is, okay, let's put a layer around the AI. And so we do things where we let it come up with it, but then we check that these things are not violated, right? And especially thinking about the robot arms. So like I was saying, the sprayer can never go outside of this box. So maybe the AI came up with a really creative solution, but it was going to do this crazy thing, and the sprayer will point at the person. Then we check that. So that's a little bit what we found is a way to allow you to accelerate quickly and not have to be as, you can't, that's the whole point of AI, right? You don't know all of this 8 billion parameters that were being tuned by a ton of data, but can you put a circle around it that says you can't violate any of these things in your solution? If you do, okay, try the next solution, right? And that's the beauty with AI, is that you will have several closed solutions. So can I check that you're not violating my safety standards, and then allow you to still have some probabilistic nature, but that probabilistic has to be checked before it's implemented.
Yeah. What you made me think about was, there's a way that a human would finish drywall, but there are also ways that humans have probably never considered, right? So kind of, you do constrain the AI to a certain kind of parameter, like you have to operate within these parameters, right? What it made me think of is, does the AI actually come up with better ways to do this, right? Like if I'm a drywall expert, oh wow, I never thought about doing that. I could have just saved myself, 50% of my time if I would have just done it this way.
I think, yeah, it's probably good to clarify. You want to put those constraints around not how it does it, but making sure that it doesn't violate a safety, right? So
okay,
we actually said very consciously, let's not try to do it like humans do, because our constraints are different, right? The humans have basically tried to minimize sanding because sanding sucks. I get it. But if you say a robot doesn't care to sand, you come up with a different solution, right? And a robot doesn't have the level of kind of adaptability that you do, but it will always spray at 0.1 meters per second, right? Like you can never ask a person, like, if you just move at this speed constantly, you'll get a perfect finish, right? And so I think it is important to not define it by how people do it, but just make sure that you're just checking the safety part of it, right? So we don't tell you exactly, to your point, we wanted to come up with something creative, like, oh, we never thought about it. Maybe we should sand hard first and then really soft at the end, because that gives us better results than trying to sand medium speed the whole time.
Right.
But we do want to kind of check that for whatever bad data, hallucination, probabilistic, it didn't decide like, hey, I'm just going to try to sand to the left and then a person could be there, right?
Yeah, the other thing I was thinking about is, like, if you're training it for the optimal output and then you're showing it, oh, here's the optimal output, right? And if all of those are human generated, maybe there's a way that the machine could have done it better. Is there a way to then train the AI to do the job better without having the actual, you can't label that data without having that optimal output that is actually better. I wonder if there's just a way to get to that state, right, without having that. I don't know.
Yeah, no, you got to a really interesting point of, like, a lot of the tasks that people do, the ultimate success is the person's okay with it. A lot of what we do, it's like the finish looks good, Like, that's not something you tell a robot, right? Like, this is good, this is bad, right? Or you have to have somebody labeling the end result and saying good, bad. So I think one of the things we have to do is be able to translate that to something that a robot can check, and that removes bias, right? Like the number of times like you can do the A/B test and you switch them and the person's still like, it's A, and you're like, but you just looked at the same thing opposite, right? And so what we spend a lot of time is like, how can we quantify what we think, so we'd have professional people finish a drywall, but then we would scan it to this crazy high resolution that they could never do. Right. And we're like, okay, that's what you think it's good. This one you didn't like because the hump was here, but if the hump was there or it was, 10% lower, you gave it a pass. Because otherwise, yeah, you're just chasing your tail. Like, right, what does it say that it was successful? I think, picking robots had a little bit easier, right? I don't care how you grabbed it, but if in the end it ended up in the other box, I call that a success. But if the end of success is a person accepting it, we need to somehow translate that to something a robot can say that, right?
What I think would be awesome is if and when you have scenarios where, what a human could accomplish, the robot does something that we never really imagined that it would do, but the outcome is better, right? So, are those scenarios possible? I'm sure they are. I'm not an expert in the space, but it'd be interesting to see those outcomes. And I think about it from the perspective of business, because if you can then show the end user, your client, right? Like, all right, well, you've been using drywall finishers to do this, but like, let me show you what our robot can do. You have never seen anything like this.
Yeah, no, actually, I have a good example of that happening.
Awesome.
Especially when we spray, you get kind of the snow accumulation approach, right? If you have a hump, you're going to see it kind of rise. But we've designed it in a way that when the sanding comes in, it's going to actually be beautiful. But a lot of times when we do our demos, people like see it at the end and they're just like, no, like you would never do that. I would fire a guy to do that. And we're like,
wait, just let
me. Yeah. And then it sands it to like a better than they could do, right? Or it sands more. They're like, why would you ever put that? Because at the end we have a better result. But it takes that they have to see both steps. When they see the first step, they even sometimes like nudge each other, like,
right,
these guys are really gonna fall flat. Oh, okay, that's not. But it was because it is so anti what they would do, right? They basically are always trying to maintain a certain thing. You're trying to hide every layer versus we're just trying to set up a place where the sanding can be successful. So it's like a little bit of a different approach. And it does take a moment to be like, oh, okay. That turned out pretty well, but it's not how I would ever do it. And you can't, right? A robot or human can never do what a robot does in terms of like precision and repeatability. And a robot really struggles with the way that a human does things, to your point of touch, right? They use a lot of like a spatula. And so you're really feeling and you have these like subtleness. We may get there, but we don't have to if there's a way to do it with kind of what robots are already good at.
Yeah. That's fascinating. So what did it look like to actually go to market, right? I mean, because you guys, it's not like you can just toss this out there and ask any consumer to do this, right? You have to actually go to business owners, public companies to pitch the idea. What did that look like when you had a prototype and you could go out there and launch POCs?
Yeah, that's definitely one of the hardest things. Early on, I think in general, when we did find people who believe that new technology is needed for construction. So it's great because they're very willing to come see or, hey, even do a test. But construction has a problem of like the schedule's very tight, right? So they can't be like, okay, yeah, experiment over here and then we'll test you. And so we actually had to become a subcontractor ourselves. We had a little bit of trouble. People like, oh, I don't know what to do. I like the idea, but how would I implement it? So we just became a subcontractor. I went and took my contractor license for drywall. And we hired our own people who were and trained them on the robot. And then we just bid jobs and say, okay, who cares if it's Johnny's Drywall or Canvas who is doing it? We promise you at the end of the day, you'll be happy. We're just using your robot. And that, we did that for about 2 years and it was good because people were starting, okay, oh, I like it. The quality's better. The price is better. Okay, let's do more. And then we got to a point where it was almost like they had seen it. It was possible. And then both us saying like scaling up that way would be really difficult, right? You have to get a license in every state. The amount of work that it took to manage like the construction business. We're roboticists, not construction business. But luckily also our customers at that point were like, okay, it can be done. It can. And so at that point we transitioned to a lease where they get trained and then they lease the machine and they use it themselves. But it had to had the step where they could see it working in the real, like, no matter what simulation I could have shown them, they would have never been happy. They needed to see it in the real world. And we needed to learn. We also learned a ton of things that we couldn't simulate in our lab. And so, but then at that point, everybody was like, okay, you guys do construction best. Here's a tool. We're going to go back to making tools.
We'll create the tools. Yeah. So, I mean, I had all types of questions going into how that would actually work. But the question I do want to ask is, what's the business? What's the business benefit? If I'm thinking about, okay, bottom line, we have to make money doing this. We have to have some type of ROI doing this. As you think about, why those actual, I'm guessing because you were a subcontractor, the general contractor hired you. What was the business benefit to them, and what was the ROI that they were able to see where they said, okay, it makes sense for us to have this?
Yeah, on the general contractors, a lot of them, the benefit is predictability, right? You can plan a lot better what a robot will produce every day. The quality was more consistent, but we actually lease to subcontractors because there's other tasks around it that the robot can't do. So they were able to see us on sites, and then we moved to them. But for them, a lot of the benefit is they have a very limited labor pool, right? They're struggling to get new people. And so the benefits augmenting those workers, those people, either because they have a ton of years on the job, but now they can work a little bit longer, or they produce more because they're using the tool, or they have these brand new people who, it just takes a while to get to be like the apprentice program is 4 years, right? It takes a lot of work to be that skilled, and the robot allows them to produce. And so a lot of the benefit is just, I need to do more with the people that I have. How do I do that? I need to protect those people because I don't have them. So when we were a subcontractor, our workman's comp rates dropped every year because we had no injuries, because we didn't have to put people up there, right? And so that safety part. And then there's some really interesting stuff that I think construction will benefit as a whole, that you can also schedule savings, predictability, right? You always hear the 80% of construction projects are over schedule and over budget.
When I was in investment banking and oh man, I heard about this all the time. But sorry to interrupt. But yeah. No. So projects going over budget, over time.
Yeah, and I think that the problem is we can't close the loop, right? Without the way construction is done, there's no feedback. You don't know if a mistake was made. You don't know who's behind. It's just, the amount of people that they have just trying to maintain the schedule is difficult. I think when you can close the loop, and this is what happened in manufacturing, right? You immediately know this box shouldn't have been there. You react to it, you correct it. I think robots will allow that extra benefit to say, hey, I should have been producing this much. You're going to need to bring more robots in, more people in to catch up, but I also can catch errors. So I think that will allow construction to have that feedback loop that we expect in a lot of things like manufacturing, but they just, if it's a person calling a person,
right,
it's just kind of this mess. So that's the other value for our customers. So we can give them that predictability, reliability, and that ability to know, hey, I did this much okay, I'm moving, I'm doing well. I can bid more jobs. I can be more strategic with my bids. I can win more work.
And so with Canvas, is it that the construction workers on site are the one, they get trained to use the actual robot? So they're kind of, does it require them to operate the robot, or is it just like set it and forget it?
Right now, there's still a lot of input that they provide, but that's kind of our goal, is to get, not fully forget it, but to get them more and more of this, like, hey, this tool that's working around me doing things right. Almost like if you started running a model and you can let it be there, you don't have to babysit it. But we do want to make sure that they're trained to understand what it's doing, what they can do with it. And so they get, it's a week-long training. They learn how to use the inputs, how to put it in, how to get the most out of it. That's also one of the important things, back to we were not trained on how to optimize a robot through things. So we trained them on those kind of things. Hey, it might look a little bit different. You might actually want to set it up this way. It doesn't make sense for a manual perspective, but let me tell you why it does make sense for the robot, right? The way that it moves and stuff.
Yeah, and I like to get your perspective on adoption. I feel like, and I could be wrong, construction is one of those industries where there's always this new gadget that's going to help you to do something, whether it has AI or not, it's going to help you to do something more quickly. So in a certain sense, construction workers are used to leveraging tools, however you want to define it, to do their job. And so a lot of the fear around AI is, hey, this is going to replace me. I don't want to use it. Did you see that in construction, or was it that, hey, this is always the scenario in our place of work? So cool, set it up for me. Let's see what it can do.
You definitely hear it, right? It's funny because the funny part is that we hear it more from the people we're not working with. Like I remember electricians are always like, it's going to take jobs. You're like, dude, I'm not even okay. But it's more like almost like you have to say it when you see a robot.
Yeah.
But what we found is that a lot of them also understood the predicament they're in, right? They're retired, they want to see it. And so when they see it in a lot of what we spend time, it's like, it's a tool, right? Your expertise, that's journeyman skill level, like you're critical to this piece. But hey, what if you could produce twice of what you produce in one day? And they're like, well, I could get paid more, right? Like that's kind of the math. I'll say also the union here, we reached out to them really early with our prototype. I still think of embarrassing of like rolling this thing in, but we're like, what do you guys think? And they were great from the beginning. They said, right, we need more people. We need people joining our union. We can't recruit people. So this could help us get people who are more interested in technology.
Right.
But we also need to improve. And they had learned that they fought every tool. Like, they talk about like they fought their roller. Like, no, we will use the brush. Nobody uses a roller.
Wow.
And they lost market. Every time they fight something, market gets lost because in the end of the day, it's going to happen, right? And so to their credit, they've been just from the beginning, like, let us help you. We still deal at the person level. There's people who are way more open than others. There's people who worry, but I think it's a lot about meeting them at their need and meeting them and understanding, like, how does this work with you? And I mean, I think anybody who does robotics would tell you, if you can augment the worker, your path is way faster than trying to be in this whole, like, nothing, can't do anything. We do it all by ourselves. And is that really the best thing? Or, getting to full autonomy takes you 20 years versus augmenting the worker. Can you get something out in 5 years and make an impact and increase your autonomy along the way and increase the adoption along the way?
Yeah. And I know we're coming up on time here. It's been a lot of fun learning about what you do. What's up next? I mean, anything that you'd like to announce, anything we should keep an eye out for as it relates to Canvas? I know we're kind of at the end of Q2, but we still got a whole rest of the year to go. So if there's anything that you'd like to shout out or anything that you'd like to make sure we look out for, we would love to hear about it.
Yeah, one of the big things that we're going to launch our new machine here towards the end of the month, June 24th. And that's just the feedback from customers, hearing a lot, getting to design a hardware more specific for their needs. So it's a pretty exciting, because at the end of the day, as we've been discussing, the hardware is the starting point. And so this system will be smaller, more maneuverable. It can get into more places. So it really starts opening up the doors to more things like finishing ceilings, which is backbreaking, as you can imagine, working in smaller, tighter spaces so that people can get more out of it. So I'm super psyched. It's many years of like that development work, but it's coming together, and the goal being that, can we continue to grow that productivity increase that we give our customers.
Awesome. Awesome. I know we only had about an hour here, but for folks who want to learn more, folks who want to kind of reach out to you or just, reach out to you about what you all offer, where should we send them?
Yeah, they can always check out our website at canvas.build, or, I'm just Maria at canvas.build. We always like to hear from people, and you'll probably be seeing more things from us, but our website has like a join our mailing list, so you can kind of see this latest and greatest. And with the new platform, we are releasing more augmentation, more AI, more things. So it's just kind of nice to have that hardware that then enables us to get all of this extra intelligence out there.
Awesome. Awesome. Well, Maria, I want to thank you for taking us to school, giving us some insight into what it looks like on the AI robotics side. Again, I appreciate you taking some time out to join us. It's been a great conversation.
No, thank you so much for having me. Always fun to chat about robots.
Absolutely.